6 hours. That's all the time you have from the first raindrop to a life-threatening disaster. Flash floods are fast, violent, and unpredictable. But here's the terrifying truth. 85% of all flood-related deaths come from these sudden strikes, not slow-rising rivers. While some nations have advanced tools, billions of people are left completely exposed. This is the global warning gap, and it's a matter of life and death. To fix it, Google researchers did something brilliant. They trained an AI not on sensors, but on the news, creating a massive dataset from scratch. The result? Accurate forecasts up to 24 hours in advance. It's on par with the world's most advanced systems, but built for everyone. This is how AI is leveling the playing field and saving lives where it matters most. Let's dive into how it works.
You know, flash floods, they're one of nature's fastest and most destructive disasters. But what if we could predict them with incredible accuracy? And what if we could do it using a tool that's learning from a totally unexpected source? Well, today, that's exactly what we're going to break down. How AI is doing just that and how it's already saving lives. Okay, to really get a sense of the stakes here, we have to start with this number, 85%. I mean, just let that sink in for a second. According to the World Meteorological Organization, the vast majority of all flood-related deaths around the world, they're not from those slow-rising rivers we see on the news. Nope. They're from these sudden, incredibly violent flash floods. And that 85%, well, it translates into a huge human cost. Every single year, flash floods take the lives of more than 5,000 people globally. That's a devastating number, and it makes them one of the deadliest natural disasters on the entire planet. So what makes them so lethal? It's the speed. 6 hours. That's often the entire window you have from the first heavy raindrops to a full-blown, life-threatening disaster. In just a few hours, the streets you walk down every day can turn into powerful, destructive rivers. So the only way to fight back against that kind of speed is to get ahead of it, right? You need time. And we know that early warning systems work. In fact, research shows that just a 12-hour heads-up can cut the potential damage by 60%. The problem is, for a huge part of the world, there's this dangerous warning gap. And this is where a really big problem comes into focus. There's this massive imbalance. While many developed nations have these super sophisticated forecasting tools, billions of people, especially in developing countries, are just left exposed. They don't get that advance notice that could literally be the difference between life and death. So you gotta ask, why is there this gap? Well, it's a fundamental challenge. It turns out predicting a flash flood is like trying to see something that's practically invisible to all of our traditional forecasting methods. To really get this, you need to know that not all floods are created equal. We're actually pretty good at predicting what are called riverine floods, the ones where rivers slowly creep up and over their banks. We have stream gauges for that, tons of historical data. But flash floods, they're a completely different animal. They are super fast, they can happen literally anywhere, and this is the key, we usually have no sensors or historical data for the exact places they're gonna hit. And that lack of historical records, that is a huge, huge problem for artificial intelligence. See, for an AI model to learn anything, it needs what's called ground truth data. It's just a reliable record of what actually happened in the past. Without that data, trying to train an AI to predict flash floods is kind of like asking it to remember something that nobody ever wrote down. So you see the problem, right? It's this classic chicken and egg situation. To predict floods, you need data on past floods. But for flash floods, that data just isn't there. So how on earth did researchers get around this? Well, they came up with an idea that is genuinely clever. They created a whole new methodology called Groundsource. The idea was, instead of looking for physical data from sensors that don't even exist, they decided to look for data where people talk about what's happening in their communities, the news. And the way this Groundsource method works is just brilliant. First, the system scans through public news reports from all over the world, looking for any mention of floods. Then, it uses an AI to actually read those articles and pinpoint the specific times and locations of these events. From all that, it builds this massive, brand new historical data set from scratch. And that is what they use to train the forecasting model. This quote from the research team really nails it. They said they used a new AI-powered methodology to extract ground truth from unstructured data with high precision. In other words, They taught an AI how to read the news, and by doing that, they created the very ground truth data they were missing. It's such a powerful idea. If the data you need doesn't exist in a nice, neat format, maybe it's just out there, hiding in plain sight. Okay, so that's the cool idea. But did it actually work? Well, the result is this incredibly powerful new tool that is already being used to help close that global warming gap we were just talking about. And the results are, well, they're transformative. This model can now provide accurate forecasts for urban flash floods up to 24 hours in advance. That completely changes the game. We're going from a 6-hour window of potential chaos to a full day to prepare. That shift can drastically reduce damage and, most importantly, save lives. But here's the part that's really mind-blowing. Just look at how well it performs. When you look at these key metrics like precision, how many predicted floods actually happen, and recall, how many real floods it caught, this new model performs on par with the advanced systems used by the U.S. National Weather Service. This is huge. It means regions that previously had little to no warning can now access a forecasting system that's just as effective as those in the most developed nations. It's truly leveling the playing field. And they're not stopping here. This is really just the beginning. The team is already working to make the model even better, expanding it to cover more rural areas, making the forecasts even more hyperlocal, and pulling in even more real-time weather data. You know, when you take a step back, this project is about so much more than just predicting floods. It's about a whole new way of seeing the world, a way to create crucial data where none existed before. It really forces us to ask a bigger question. If AI can find these invisible floods just by reading the news, what other solutions to our biggest challenges are also just hiding in plain sight, waiting in the stories we tell?